Hi guys, we're going to start section 1.4 today for sets of outcomes in trees, and I personally think that stuff is going to be a bit easier than what we've been doing so far. So, what we're basically doing in this section is finding the probability for outcomes or how many different kinds of outcomes there are for a given scenario. So let's go on to some vocab first, get that out of the way. So first off, we have an experiment. The meaning is an event whose outcome is uncertain. So, what are some examples of experiments? Well, often in probability, we'll get examples of things that you'll see as maybe flipping a coin. And bear with me, I accidentally left my stylus at school. So, flipping a coin, that could be one of our experiments, because when you flip a coin, you don't know if it's going to land on heads or tails. It's an uncertain outcome. So, what's another sort of outcome that's uncertain? Well, how about rolling a die or rolling multiple dice? Standard die has 6 different outcomes, and you don't know which one it's going to be. That makes it an experiment. It's uncertain. The last one could be maybe a multiple choice question on a test. We'll see some of those on our examples, or something with a true false. We don't necessarily know what the outcome is. So, with all of these outcomes, we have a way of generating all the possible ones, and that's called the sample space. So, if we go back to this, what's the sample space for flipping a coin? Well, what are the two outcomes you could get when you flip a coin? You would get heads or tails. I actually have one right here. There's two sides, heads or tails. So the sample space we denote as S for sample space equals, and you don't have to write out heads or tails, you would just write H for heads, T for tails. That would be the sample space for that. What's a sample space for rolling a standard 6-sided dice? We're going to assume that it's standard unless it tells us differently. So standard die, 6-sided, well, what are the numbers we could get? We could get 1, 2, 3, 4, 5, or 6. Those are the only numbers on a 6-sided die. How about the sample space for a 4-question multiple choice question, 4 outcomes? Well, it'd just be A, B, C, or D in general. So the sample space for our multiple choice would be A, B, C, or D. And how about true, false? Well, something's either true or it's false. So I ran out of space. So the sample space for this is true or false. So those are all the possible outcomes. That's what the sample space is. And last time we have this thing called the multiplication principle. And then fancy words, it says in a K-stage experiment with N1 outcomes at stage 1, N2 outcomes at stage 2, regardless of the result in stage 1, N3 outcomes at stage 3, previously of what happened, so on, and NK outcomes at stage K, regardless of what happened earlier, then the number of elements in the same space is N1 times N2 times so on and so forth till you get to your last element. Now, what is that really saying? You can think about it this way. If I were to roll a die 3 times, roll a die 3 times, well, the first time we would have 6 outcomes, right? That would be our N1 here. The second time, can you roll the same number twice with a die? Yeah, just because I roll a 2 on my first roll doesn't mean that it's magically gone. I could still roll a 2 on my second roll. So there's still 6 total outcomes. Those are called independent of each other. It doesn't matter what happens at first because I could get it again. So we're just going to end up multiplying to see how many outcomes there are. If we roll it 3 times, we'll use that same sort of logic. It doesn't matter what I got earlier. I could still have 6 different outcomes. So I take 6 times 6 times 6. So if I roll a die 3 times, there are 216 different outcomes. So how about if I toss one coin? So I flip a coin for heads or tails. So flip coin and roll die. So if I flip a coin and roll die 1 time, so how about roll 1 die? Does the outcome of the coin affect the outcome of the die? No, because no matter what I flip with that coin, it doesn't matter. It's not going to change what I get with the die. So how many outcomes were there for the coin? There were 2 outcomes for flipping a coin. How many outcomes were there for a 6-sided die? 6. So there are 12 total outcomes. So that's basically the gist of what we're going to be doing today. Let's take a look at some examples. So an experiment consists of flipping a coin, so 1 coin, and then rolling a die, so 1 die, noting which side comes up each time. What is the sample space of this experiment? We just kind of talked about this, but this time it wants us to come up with the sample space. So here's what we're going to do. We are flipping 1 coin. So I'm going to start right here and draw a tree, kind of like we did first semester. What are the 2 outcomes of the coin? Well, I could get a heads or I could get a tails, right? That's all that I can get when I flip a coin. And when I roll the die, there are 6 different outcomes I could get. 4, 5, 6. But there are 6 different outcomes I could get if I rolled tails too, right? 4, 5, 6. Because I could get a heads and roll a 1. I could get a heads and roll a 2. Heads and roll a 3. Heads and roll a 4, 5, and 6. Likewise, I could get a tails and roll a 1, a tails 2, tails 3, tails 4, 5, and 6. So the sample space that we would be looking for, if it says to what is the sample space, I just list all the outcomes. So I could flip for a heads and roll a 1. I could flip for a heads and roll a 2. Flip for a heads, roll a 3. Flip for a heads, roll a 4. Flip for a heads, roll a 5. Yeah. Flip for a heads, roll a 6. So those are all the outcomes if I got heads first. What if I got tails first? Well, I could get a tails, roll a 1. Flip for tails, 2. Tails 3. Tails 4. Tails 5. And our tails 6. So that's the sample space for this experiment. And that's how we find it. So here, a local pizza company has 3 sizes of pizza, 2 types of crust, and 4 available toppings. How many different types of pizza combinations could someone order? So you ask yourself, are these dependent? How about 3 sizes? Let's assume small, medium, and large. If I get a small pizza, does that affect the type of crust I'm getting? No. Does it affect the toppings I'm getting? No. So what we're going to end up doing is, because they don't affect each other, we'll just have to end up multiplying them all together. So the first space we have is N1, we have 3, Use your imagination that that's a very good 3. We have N2 with our 2 types of crusts, and our N3 is 4 available toppings. So 3 times 2 times 4, we have 24 different outcomes. So here, we have an experiment consists of flipping a coin 4 times or until a heads is flipped. Find the sample space of this experiment. Now the wording here is important. We're flipping the coins 4 times or until a heads is flipped. So let's start at the very beginning. So here we are right now. Let's say we flip a coin. Heads is up here, tails is down here. Well, it said we're going to flip the coin 4 times or until a heads is flipped. What happens if we flip a heads? We're done, right? That would be our sample space. But what happens if we flip a tails? We'd go on. From that tails, we could flip a heads, right? Up here, heads, or we could flip another tails. If we flip that heads that time, we're done, but we flipped a tails first. So I should have had our sample space going already. We could have had our heads and just have stopped. We could have flipped a tails first and then a heads, and then we'd stop. If we flipped a tails, we would have kept going. And from that tails, we could have flipped another head, or we could have flipped a heads. This was our 3rd flip, by the way. Or we could have flipped another tails. If we flipped the heads, we would have stopped and we would have gone tails, tails, heads. So that would be the 3rd in our sample space. Tails, tails, heads. Then lastly, if we got that other tails on our 4th flip, we're stopping regardless. It does not matter because we said we're flipping it 4 times or until a heads is flipped. Here, this was our 4th flip, so we have to take both of these outcomes. So what would the outcomes be? Well, it would be tails, 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 heads. So T, 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 H, or tails, 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 tails. I'm going to write it over here. T, 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 T. So let's keep on going. So here, sorry about that. The Cupcake Club has 6 members. Excuse me, my notes are being a little annoying. Sorry about that. The Cupcake Club has 6 members. There they are: Sam, Chris, Mark, Joe, Alex, and Melvin. And the club needs to vote for a president and a vice president. How many possible outcomes are there? We're going to have to think just a little bit on this one. So if they have 6 members and we go to vote, how many many outcomes are there for president? Well, any one of them could be the president, right? So Sam could be president, Chris could be president, Mark could be president, Joe could be president, Alex could be president, or Melvin could be president. So for president here, there's 6 different outcomes because any one of those 6 could be president. But then how about for vice president? Can you be both president and vice president? No, you can't. So if Sam gets the president, she's out of the running for vice president. How many are left? 1, 2, 3, 4, 5. Same with Chris. If we crossed Chris off, we'd have 5 different outcomes. Mark, 5 different outcomes. So because you can't be both president and vice president, there's only 5 different outcomes, so we have 30 possible outcomes here. So here, a multiple choice test has 50 questions, each with the answer choices of A through D. How many possible ways are there to answer all 50 questions? So we ask ourselves, if there are 4 different outcomes with our first question, how many ways are there to do it? Well, you could answer A, you could answer B, you could answer C, or you could answer D, 4 different ways. The next one, as we're going through, how many different ways are there to answer the next multiple choice question? Well, you could answer A, B, C, or D, so 4 different ways. All right, how about the next one? We could answer it A, B, C, or D, so 4 different ways. So hopefully you've picked up on a trend here. If there's 50 questions, we could answer it 4 different ways 50 times. So the way we denote this is 4 to the power of 50. And no, I do not expect you to simplify something that big because that's a really big number. So there's 4 to the power of 50 different outcomes because there were 4 choices. So example 6, we have a quiz contains 4 true-false questions followed by 2 multiple choice questions, A through E. How many possible ways are there to answer all 6 questions? So there's 6 questions total, so I'm going to go ahead and draw 1, 2, 3, 4, 5, 6. So how many true-false questions are there? Well, there'd be a true-false number 1, true-false number 2, true-false number 3, and true-false number 4. How many multiple choice questions are there? There's multiple choice 1 and multiple choice 2. So think about the true-false. How many ways are there to answer a true-false question? You could answer it true. You could answer it false. 2 ways. And that's for all of them. So there's 2 different ways to answer all true-false questions. Now with our multiple choice questions, we have A through E, which is 5 choices this time. So make sure you're reading how many choices there are on multiple choice questions. Why 5? Because we could answer it A, B, C, D, or E. So we'll just have to put over here a 5 and another 5. Now we just do the math real quick. What's 2 times 2 times 2 times 2 times 5 times 5? That ends up being 400. There's 400 different outcomes on a test set up like this. Last one we're going to do today is example 7. So for prom, you and your date go out to eat at Applebee's and have the prom special where you get an appetizer from a list of 4, 2 entrees from a list of 5, and 1 dessert for a list of 3 for the low price of $25. No, this video is not sponsored by Applebee's, but kind of wish it was. How many possible meal combinations can you and your date purchase? So we're just going to have to go through and ask ourselves, we only get 1 appetizer. I know it got a little cut off there, I'm sorry, but we only get 1 appetizer, we get 2 entrees, and we get 1 dessert. So here's our appetizer, A, here's our entrees, E, here's our dessert, D. So how many different choices are there for our appetizer? There's 4. How many different choices for the entree? 5 for both of them, because my prom date and I, we could get the same thing. That's why we don't need to take 1 away this time. Then how many choices are there for our dessert? There are 3. So we multiply 4 times 5 times 5 times 3 to get 300. You can plug that in a calculator, see if that's right. So that's all we're going to do today. Tomorrow we're going to get to a little bit more, but it's just a lot of multiplication, I think. And as long as we think just a little bit, like example number 4, you can't be both president and vice president. We just need to make sure we're reading how many multiple choice questions are there, how many does it 1 of each, things like that. I don't think this is quite as bad. So as always, if you have any questions, please don't hesitate to let me know. Just send me a Canvas message. If you want to go over things via Zoom or WebEx or whatever, just let me know. And Other than that, hope you're staying warm. Hope you're staying safe. Have a great rest of your day. We'll see if we're in school tomorrow. If not, I will see you when the weather permits us. Bye, guys.